Hi guys, here's the video that goes over the multiple choice review packet for Algebra 3-4. This is actually one of two videos. The first video is going to go over questions 1 through 25, and then the second video is going to go over questions 26 through 50. Now, if you have your own graphing calculator, I would recommend getting it out as you're watching this video because I'm going to walk you through some keystrokes. If you do not have your own graphing calculator, I would recommend writing down the keystrokes in your review packet and then practicing them once you're in class and using your teacher's graphing calculators. Alright, so 1 and 2, you're solving exponential equations. So exponential equations, if it's possible, you want to have the same base. So your base for this right-hand side is a 6. So we want to manipulate the left-hand side so it's also a base of 6. So we do have the 6, it's just not a normal 6. It is a 1/6. So what I can do to make that a regular 6 is take the reciprocal. Now taking the reciprocal deals with negative exponents, so I can write this as 6 to the negative 1. That's going to give you that 1/6. So 6 to the negative 1, still being raised to the x, equals 6 to the 3x plus 4. Now I'm raising a power to a power right here, the negative 1 and the x, so I can go ahead and multiply those. So that's going to give you 6 to the negative x, negative 1x, equals 6 to the 3x plus 4. Now if you notice your bases are the same, you have the 6 and the 6, so you can go ahead and drop your bases. So that gives you negative x equals 3x plus 4. I can subtract 3x from both sides. That gives me negative 4x equals 4. So x equals negative 1. So the correct answer for that is B. Number 2, I'm going to do the same thing. I have my base of 5 right here. So I want to change that 1 over 25 to a regular old 5. Well, 25 is the same thing as 5 squared. Now, since it was 1 over 25, that's going to be 5 to the negative 2. And then to the 3x equals 5 to the 2x minus 16. Again, I'm multiplying my exponents because I'm raising a power to a power. So that's going to leave me with 5 to the negative 6x equals 5 to the 2x minus 16. I can go ahead and drop my bases since they are now the same. So I now have the equation negative 6x equals 2x minus 16. Subtract 2x from both sides, that gives me negative 8x equals negative 16. So x equals positive 2. Now if you go to your answer choices, we do not have a positive 2. So this question right here has a typo. Sorry about that. So that negative 2 should actually be a positive 2, which makes your answer letter B. There's 2 more typos in your review packet, which I'll point out as we get to them. So again, I apologize for that. Okay, so we have the exponential equations. Now we're looking at logarithmic equations. So you always want to make sure your logarithm is isolated. So this logarithm has a 3 in front, so I'm boxing it because that's what I want to isolate. So I need to get rid of the 3, so I'm going to do that by dividing both sides by 3. That gives me log base 8 of x minus 1 equals 2/3. Now you have 2 different logarithmic equations. You either have a log equals a number, which is what we have for this equation, or you have a log equals a log, which is what you're going to see for number 5. So if you have a logarithm equals a number, what you're going to do is you are going to change to exponential form. Okay, so you start with the base of the logarithm, come across your equal sign, that's going to be your exponent, come back across, and that's what your equation is going to equal. So you're going to have 8 to the 2/3 equals x minus 1. 8 to the 2/3, I can plug that into the calculator. I'm going to type in 8. You have that little caret key, that's going to create your exponents. So 8, little caret key. 2/3 is the same thing as 2 divided by 3. And then hit enter, and that's going to give you 4. So you get 4 equals x minus 1. So you get x equals 5. So your answer is D. Number 4, we still need to isolate our logarithm, but now we have two numbers that we need to move around. So I'm going to start by adding the 3 to both sides. So that gives me log base 4 of x minus 1 equals 5, because again, I added 3 to both sides. I can divide both sides by 5, because again, want to isolate that logarithm. So I get log base 4 of x minus 1 equals 1. I have logarithm equals a number, so I'm going to change to exponential form. So I have 4 to the first equals x minus 1. Well, 4 to the first is just 4. Solve for x, and once again, you get x equals 5. Number 5, you have a log equals a log, probably the easiest logarithmic equations to solve, because what you can do is you can just drop your logs, since their bases are the same, which they will be on your final. So you get x plus 12 equals 4x plus 6. I'm going to solve for x, so I'm going to subtract x from both sides. That gives me 12 equals 3x plus 6, subtract 6, 6 equals 3x. So you get x equals 2, which is C. Number 6 is an exponential equation, but you cannot get them to the same base. 56 can never be broken down into 5s. So what you can do is you can take the log of both sides to bring that x down. So I'm going to go ahead and take the log of both sides. So that'd be log of 5 to the x equals 56. Sorry, that's my calculator. I was moving it on my desk. So now that I've taken the log of both sides, which I actually didn't, forgot my log over here, I can bring that x down because that's one of our logarithmic properties. So that's going to be x log of 5 equals log of 56. I can get x by itself by dividing both sides of log by log of 5. So I get x equals, and this I'm just going to type into the calculator. So I have log, going to type in the 56. Make sure you actually close out that parenthesis in the calculator before you divide by log of 5. Otherwise your answer is going to be all sorts of messed up. And that gives us 2.5. So your correct answer for this is D. Now, let's say you get to your final exam, you look at this question, and you're like, holy crap, I don't know what to do. What you can do, since it is multiple choices, you can test out your answer choices. So you can take each one of these and plug it in for x. So take 5 to the negative 1.05. That gives you 0.18. That's obviously not 56, so that's not the answer. Take 0.35, plug it in for x, so 5 to the 0.35 gives us 1.76, again not 56. Take 1.05, plug it in, gives you 5.42, again not 56, but if I take 2.5 and plug it in, that gives us 55.9, which pretty much is 56. So you can use your answer choices since it is multiple choice. Number 7, which expression shows the value of $10,000 of a $10,000 investment after it has grown by 2.25% per year for 12 years? So we first want to start by changing this percent to a decimal. Going to move that decimal over twice, so that's 0.0225. It says that your investment is growing, so this represents exponential growth. So our equation, we're going to start with the initial value, which is 10,000. And then exponential growth or decay is always 1 plus for growth or 1 minus for decay. But we're dealing with growth, so I'm just going to go with 1 plus. And then whatever your rate is, so 0.0225 to the t. But we do know what the t is. T is 12 years, so I can go ahead and put in 12. This we just need to simplify what's in the parentheses since we're just looking for the expression. So that's 1.0225 to the 12th power. So your correct answer for that is letter D. Now be careful, because if you do not change your percent to a decimal, that's probably an answer choice. Also, if you don't change it to the correct decimal, that's going to be an answer choice as well, so just be careful. Which of the following functions is an example of exponential growth? So exponential growth, you look at your base of your exponents. So letter A is not even a choice because that's the next to the 7th. That's not an exponential function. D is linear, so you can cross that off. So that means you're choosing between B and C. So for growth, your base has to be bigger than 1, so your answer is going to be B. Letter C is actually an example of exponential decay. Number 9, Scott needs at least $2,000 for a down payment on a car. He invests $1,000 in a bank that pays 6% interest compounded annually. The amount of money in the account can be expressed by the exponential equation. A equals 1,000 times 1.06 to the t. Approximately how many years will it take him to meet his goal? So I already gave you the equation. That makes life a little easier. Okay, so since it is multiple choice, we might as well use the answer choices. So I'm going to go ahead and take 2 and plug it in for t. So I have 1,000 times 1.06 to the 2nd power. And when I do that, that gives me 1,123.6. Scott needs at least 2,000, so that's not going to work. So what I can do is I can plug in 5, see what that gives me. 5 gives me 1,338.2. Again, not going to work. Let's try 10. That gives me 1,790.8. Getting warmer, but still not quite there. So obviously the answer has to be 12, but let's double check it anyway. So that's 2,000. 12.2, which is at least 2,000, so your answer is going to be D. All right. Number 10, I would recommend just graphing graphing the function in the calculator. So you're going to take 2 to the x plus 1. So I'm going to write down the keystrokes so you can remember. You're going to go to y equals. I'm going to type in 2, use the little caret key to the x plus 1, and then hit graph. And the graph that closestly, I don't know if that's a word. The graph that closest resembles the one on the calculator, the closest, is going to be letter A. Sorry, getting all jumbled up with my words. Yeah, so the best way to do this one is to graph it in the calculator and then from there match it up with one of the graphs. Alright, number 11. The point negative root 2 comma root 2 lies on the terminal side of an angle. Find sine of theta. So any trig stuff where you're finding a trig function, I would highly recommend that you start by writing SOHCAHTOA, because that'll help you out when you're figuring out your ratios. I give you a point, so when I give you the point, you should automatically think, oh, I need to graph that. So negative root 2 and positive root 2 is going to be in the second quadrant because x is negative and y is positive. So I'm going to go ahead and plot the point. Doesn't have to be accurate, we're just doing it for a sketch. And what I can do is I can make a triangle. So I can go straight down, go straight to the origin. So the horizontal distance is negative root 2, vertical distance is positive root 2. Now to be able to find the hypotenuse, you're going to use the Pythagorean theorem. So I have negative root 2 squared plus root 2 squared equals c squared, which will be your hypotenuse. I'm going to use my calculator. So negative root 2 squared plus square root of 2 squared gives me 4. So c equals 2. So that means your hypotenuse for this is 2. Okay, we want to find sine. So looking at your SOHCAHTOA, that's why I had you write it down. Sine is your opposite over your hypotenuse. So your theta is always the one that's right next to the x-axis. So my opposite side is the root 2, and my hypotenuse is the 2. So that means sine of theta is going to be root 2 over 2, which is c. Number 12 is very similar, so find cosine of theta when theta is an acute angle, and cosecant of theta is 5 over 2. So again, we're finding a trig function, so I'm going to go ahead and write SOHCAHTOA. It'd be helpful if I could spell it. Okay, so cosecant, you need to know, cosecant is the reciprocal of sine. So since cosecant is 5/2, sine is going to be 2/5. Now again, I am going to draw a triangle. It does say that the angle is acute, which means your angle has to be between 0 and 90 degrees. So that's going to put your triangle in that first quadrant. So sine, using SOHCAHTOA, sine we know is the opposite over the hypotenuse. So I can go ahead and label those two sides on my triangle. Here's my theta. Opposite side is going to be 2. Hypotenuse is going to be 5. And once again, we can use the Pythagorean theorem to find that other side. So I have a squared plus b squared equals c squared. So a squared plus 4 equals 25. A squared equals 21. Take the square root, and you get a as the square root of 21. So I can go ahead and label this side as the square root of 21. Now the original problem says to find cosine. So looking at my cosine, cosine is adjacent over hypotenuse. So my adjacent side is the square root of 21, and my hypotenuse is that 5. So that means cosine of theta is going to be the square root of 21 over 5, which is b. (13) is the same scenario. Again, gonna write SOHCAHTOA because it's helpful. Secant is the reciprocal of cosine. So if I know that secant is 4, that means cosine is 1/4. Cosine is the adjacent over the hypotenuse. So since I know that, and I also know that the angle is acute, again, I'm going to draw my triangle in that first quadrant. So I know my adjacent side is 1, my hypotenuse is 4, there's your theta. We can still use the Pythagorean theorem to find the other side, so I have 1 squared plus b squared equals 4 squared. So 1 plus b squared equals 16. So b squared equals 15. So b is the square root of 15. Okay, and I am trying to find tangent. Tangent is opposite over adjacent. So my opposite side was the root 15, and my adjacent side is 1. So that's going to give me root 15 over 1, which is just the square root of 15, which is B. Four and 5, I'm just going to do that right into the calculator. You did use the unit circle for, not 4 and 5, 14 and 15. You did use the unit circle for those, but you don't get the unit circle on the final, so might as well just use the calculator. Big important thing. Make sure your calculator is in radian mode. So you can do that by hitting mode, which is right next to the second button, scrolling down to the third line and highlighting radian. So you can hit enter to do that. Now what I'm going to do is I'm going to type this right into the calculator. So I'm going to type in cosine 2 pi. So to get pi, you're going to hit second. Here's how you do pi on the calculator. Second, and then your little caret key. You can see there's a little pi above that. And then 2/3, so that's 2 pi divided by 3. And your calculator is going to spit out a decimal, which is negative 0.5. Well, negative 0.5 is negative a half, which means your answer is A. Now, let's say you get a decimal that you do not recognize. What you should do is you should change all of your answer choices to decimals. So negative 1/2 is negative 0.5, 1/2 is 0.5. Negative root 2 over 2, we can use a calculator to get that as a decimal. So that's negative 0.707. And then square root of 3 divided by 2 as a decimal is 0.866. So you're just going to match up the decimal that you get once you plug the expression into your calculator with one of the decimals as your answer. So your answer is still going to be A. For 15, we're going to do the same thing, but if you notice, you got this little negative 1 sitting on top of your cosine. That's the inverse cosine. So you're going to start by hitting second first, and then cosine of negative 1. And then you hit enter, and then that is going to give you 3.14. 3.14 we all know is an approximation for pi, so your answer is going to be A. Now again, if you get a decimal that you do not recognize, what you should do is you should change all of your answer choices to decimals. So that's 3.14. Pi divided by 4 is 0.785. Pi divided by 2 is 1.5057. 1 and 2 pi is 6.28. And match up the decimal with the answer that your calculator gives you. 16, which function has an amplitude of 8 and a period of 2 pi? So your amplitude is 8, which means A equals 8. The period of 2 pi, so to find period is 2 pi divided by b. So we know the period is 2 pi, so I have 2 pi equals 2 pi over b. I can solve for b, so that's going to give me b equals 2 pi divided by 2 pi. Since this is a fraction, you can cross multiply and solve for b. So you get b equals 1. Now, to write the function, all of these are signs. So your function, A is always in front. B is what is attached to x or to theta, depending on how it's, depending on the notation. So we know that A is 8 and B is 1, so that's just going to be 8 sine of x, which is letter D. Um, 17, you're graphing the sine of x. So sine always starts at the origin. This one starts at the origin, so it could be A. This one starts at the origin, so it could be B. Cosine, this one starts at your positive amplitude, so that one starts at a crest Same thing with letter D, which means C and D are not answer choices. C and D are actually graphs of cosine instead of sine. So you just need to pick between A and B. Now the number in front of your trig function represents your amplitude, so that means your graph needs to go up to 2 and down to -2, which is what the graph of letter A does. Letter B only goes from 1 to -1. Now you can graph this in the calculator if you want to. You can go to y equals. You can type in 2 sine of x. The only thing is you have to pay attention to the scaling, because normally our graphs go from -10 to +10. This one goes from -6.28 to +6.28. So if you want to, you can adjust the window by hitting the window button and then changing the scale so that it looks like the scales for these graphs. So my x minimum is the -6.28319, which is actually -2 pi. X max is the +6.28319. I'm going to go ahead and just ignore the x scale since we're just looking for the general shape of the graph. The y min goes from -4 to +4. And then if you hit graph, it'll show you that your answer should be letter A. So you can use the graphing calculators for this if you want to. Okay, 18, convert 3 pi over 4 radians to degrees. So with radians to degrees, you're either multiplying by pi over 180 or 180 over pi. Since I'm trying to get rid of the pi with the radians, that means the pi has to be on the bottom. So I'm going to go ahead and put 180 degrees at the top. So pi's cancel. I can multiply straight across. 3 times 180 is 540 degrees over 4, which is 135 degrees. So your answer is A. What is the least positive coterminal angle, or what is the least positive angle measure that is coterminal to 19 pi over 6 radians? So coterminal angles are angles that share the same terminal side. So to find coterminal angles, you are either going to add a full rotation or subtract a full rotation. A full rotation in radians is 2 pi. A full rotation in degrees is 360. Now if I were to try to add 2 pi to this, so I can put this in the calculator, just don't put the pi's in there. So I'm going to do 19 divided by 6 plus 2. You can hit math and then select frac to change it to a fraction. That's going to give me 31 pi over 6. Well, if you look at your answer choices, there's obviously not a 31 pi over 6, and this question does not have a typo, which means instead of adding 2 pi, let's cross this off, you are actually supposed to subtract 2 pi. So I'm going to have 19 pi over 6 minus 2 pi. So 19 over 6 minus 2. Again, don't put the pi's in the calculators. It's just going to give you decimals that you're not going to be able to math frac. So that's going to give you 7 pi over 6, which is letter B. Number 20, convert 60 degrees to radians. So now we are starting with degrees, changing to radians. So since I'm starting with degrees, I want to cancel out the degrees. So I'm going to put 180 on the bottom. I'm going to put pi on the top. Degrees are going to cancel. You can go ahead and multiply straight across. So that's going to give you 60 pi over 180. You can use a calculator to reduce that if you want to. Just again, don't put the pi in there. So that's going to give you pi over 3. So your answer is B. By the way, to do a fraction in the calculator, if you don't want to do 60 divided by 180 and then math frac it, you can hit alpha and then y equals. And it's that first option. So if you do that and put in 60 over 180 and then hit enter, it's automatically going to reduce it for you. Okay, Amplitude and period of this function. So again, amplitude is what's in front of your trig function. So amplitude is 4. Period is 2 pi divided by b. There's your b. So 2 pi divided by 2 is just going to give you pi. So amplitude is 4, period is pi. So your correct answer is C. Alright, 22, what is the phase shift of this function? Your phase shift is negative c over b. So negative c, b is the number that's in front of x. There's your c, so that's negative pi over 2 divided by 1, so that's just going to give you negative pi over 2, which is letter D. Now, if your b is 1, your phase shift is always just going to be the opposite of what you are adding or subtracting. So since you are adding pi over 2, the phase shift would be negative pi over 2. 23 is a trig modeling question. A ball is hanging from a spring. The ball is pulled 5 inches below its resting position and then released. The period of the motion is 8 seconds. Which function could model the ball's height in inches t seconds after being released? So it's helpful to draw a graph. It's just a sketch to help you figure out what's going on. So when I pull the ball down, the ball is starting down here. And then what it does when I release it is it goes back to its original resting position, and then it bounces up or goes up, comes back down, and so forth. Okay, so the ball is oscillating up and down. Now, if you look at your trig function starts at a trough. Okay, so that means we're going to use cosine. Sine starts at the origin. Sine always starts right here. Whoops. Sine always starts right there, okay? Cosine is either going to start at the bottom or at the top. So we can eliminate C and D as answer choices because those are sine functions. Now, a positive cosine function starts up here and then goes down. Does something like this. Negative cosine is going to start at the trough, so your answer has to be B. Now, where does that pi over 4 come from? So the pi over 4 comes from the fact that the period is 8 seconds. So period is 2 pi divided by b. I know the period is 8. So that means b is going to be 2 pi divided by 8, which is where that pi over 4 comes from. Alright, so your answer is still B. Alright, so getting to probability. Let U be the set of all integers from 1 through 15. So there's your universal set. A is 1, 3, 5, 7, 9. B is 1, 3, 11, 13, and 15. The set 1, 3, 5, 7, 9, 11, 13, and 15 can be described as one of these. So the notation you have to be familiar with. So I'm going to go ahead and write that up here. That is going to be A or B. Sorry, that is A and B. It wouldn't help you if I gave you the wrong definitions. That is A and B, that's the intersection. This is the union, which is A or B. So the intersection, the and, is going to be what's in both of them, okay, what they both have in common. A or B, the union, is going to be A or B, so listing all of those numbers together. This little apostrophe means the complements, so then that means not. So for instance, if I had A apostrophe, it would be all of those numbers that are not A. Okay, so let's look at the set. We have 1, 3, 5, 7, 9, so we have those numbers which are in A. B has 1, which we already have. B has 3, which we already have. It also has 11, 13, and 15. So that can be described as the set as A or B, which is going to be letter D, because it's the union. All right. Number 25, you spin the lettered spinner shown below. Event A is landing on a vowel. So A are the vowels, which we have are A and E. Event B is landing on a consonant. So that is B, F, D, and C. What is the intersection of A and B? Well, you don't have any vowels that are consonants, so that is the empty set. So your correct answer for that is going to be A. Alright, so that covers all of the material for the first half of your final exam review. I hope that helps.